going?
Yeah.
All right, so we have a simple circuit setup, 2 light bulbs, a resistor, or a switch, and when we turn it on, we can see that those 2 light bulbs are not equal. All right, so obviously they are in series, so therefore they have the same current. They have the same current, but they have different resistances. Since power, actually, I'm going to come down that way you can see a little bit better. Since power about light brightness is about power, so power equals I squared R. They have the same I, so the bigger R will have the more brightness because it has more voltage. Okay, we can check that out easily enough. There's 20 volts. I'm not sure if you can see that or not. Yes or no? Okay, and so now just got to find which one of these. Still see it or not? Okay, so when we go across, we see that the total voltage is somewhere around 3. This takes 0.78. This takes 1.5, which does not equal 3. And actually, why that is not 3, I don't know. There's some other resistances someplace I haven't figured out. It might also be that there's some EMF stuff happening. Okay, but we saw that one was a bigger voltage than this one because it's a bigger resistor. Now, but what if I take this and I undo the switch? Now we were to check the voltage, and the voltage here is 0 because there's no current. Voltage here 0, no current. The voltage here, no current, is
3.
the EMF of the battery. A weird thing that there's no current flowing, but there's EMF. We remember this from the second lab we did? And if we think about it in the way that we have proportional resistances, the bigger the resistor, the bigger the voltage. And since that's a ginormous resistor in comparison to these things, it's going to take all the voltage. All right? Now let's do something a little weird. I've got to take my meter here, and instead of reading volts, I'm going to go down here to ohms. Okay? The 1, by the way, means off scale, or I heard someone say open circuit, whatever it is. So if I connect these two, it should read around 0. Yes? Mm-hmm. Okay? So now I'm going to take a voltmeter. I'm going to put it to volts. Okay? So that says voltmeters. I have that in the correct spot. Now I'm going to take those and I'm going to put them across this. And I'm going to read the ohms across a voltmeter. And it reads off scale, doesn't it? All right, so let's go to a higher scale. A couple higher scales. That's like probably 2,000 something, right? Still reads off scale. Reads off scale. Reads off scale.
Now it's reading
No,
something.
should have read something. Probably about
0.25.
yeah. So it's like 200,000 ohms or more. Okay, so let's think about that. If we have, again, a break in the circuit, a gigantic resistor reads the whole voltage, right? Mm-hmm. And if I were to put a small resistor over here, it would decrease the total resistance. By putting a big resistor here, remember, with a big resistance, it reads just less than the smaller resistor. But if this is 1,000,000 and that's 5, it reads 5.000. All right? And none of the current goes around because it's a giant resistor. So when we have voltmeter is a giant resistor. Now I'm going to move this over, and I'm going to put this on 10 amps just to protect it, and I think that's the 10 amp setting. Now let's see what 10 amps does. Red on this, I know it's going to happen, so I'm going to jump down here. And what does that read?
0.
0. Drop it down even more, and it reads 0. So an ammeter reads very, 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 very low resistance. Let's think about that. So I want to read the current. So I open the circuit, I insert an ammeter. What does that do for me? Well, since it's such low resistance, it doesn't change the current of the circuit. So now what have we learned? We've learned that if you want to read voltage, you need a high resistance, very high resistance, so that it reads the total voltage and that it doesn't take current. Because what if it was a smaller resistor? Then it would just it would change the resistance of the circuit. But for an ammeter, the resistance is very low. You put it inside the circuit and it doesn't change the current because it's such a low resistor. We good? All right, that's it.